dynamic array implementation. What is the drawback with this static array implementation or simple array implementation? It is that I am having fixed size. I am simply writing int s of 10. I am having fixed size. Okay. So, I cannot increase this size. If new elements are being inserted, I cannot insert. For that, we in programming we have a concept of dynamically allocating memory. So, that concept I will be using it here. So, the second way of implementing is dynamic array implementation, where we will be using dynamic memory allocation techniques to allocate the memory. So, before we go into this dynamic memory allocation, let me recall what is the DMA, dynamic memory allocation technique. So, we have two functions, calloc and malloc. Okay, we have two functions, calloc and malloc. Now, you can use any one of them. This is continuous allocation, this is random allocation. Malloc means it will allocate memory at different locations, maybe not different at the same place, but in different blocks, whereas calloc will do in continuous in a single block. So, if I create an array using dynamic memory allocation using calloc or malloc, if I create some 5 elements, if I reserve 20 bytes, if I reserve some 20 bytes using dynamic memory allocation technique, okay, using these two, calloc and malloc, what is the other function? If I want to insert sixth element, what is the function which I have to use? It is realloc, realloc. This is the third function in dynamic memory allocation. What is the syntax of this realloc? If earlier we had 5 elements, now you have to tell realloc of 10 elements into size of int. Okay, that we will be writing here. Realloc 10 into 5. Now that array A, which was of size 5, now it became a new array which is of size 10. It became of size 10. So already when it was A of 5, I had 5 elements. Already when it was A of 5, I had 5 elements, 1, 2, 3, 4 and 5 in that. But I came to know that I want to increase more elements into that. So I will be using realloc in between the program, and I will be extending the size from 5 to 10. After extending this, what you have to do, after extending this, it will be a new memory allocation. It will be a new memory allocation of 10 elements. Okay, and you have to copy all these elements from here to in this location. You have to copy all these elements from there to here and continue inserting in this location So, in dynamic memory allocation technique, kind of a drawback we can say that if you already use calloc and malloc functions and declare an array of size 5, means 5 elements, okay, of 5 elements. Later you want to insert, you want to increase the size, you definitely have to use realloc function. What does realloc does? You have to give some extra size. That existing 5 plus extra 5 combined together, you have to give 10 here. That number you have to mention here. So it will allocate a new memory block. Then the old memory block which had 5 elements 1, 2, 3, 4, 5 have to be copied into this. Okay, that is one drawback. Why? Unnecessarily I am using A of 5 space plus A of 10 space in my RAM. These 5 bytes are being used and then this 10 bytes. So you are copying the elements from array to here. How do you copy? Using a loop. Loop means again order of n. Why? I have to copy the elements from this to this. It is internally being done. We are not doing it. Internally, automatically it is being copying it. But internally, it is using some extra space also. It is using some extra space and some computation. Right? So this is the drawback even for dynamic memory allocation. Though you feel that I can extend the size of the array dynamically by using DMA, by using some dynamic memory allocation techniques, but still it has the drawback. Okay. What is the drawback? The way of incrementing the array size is too expensive. It is too expensive. Time complexity increases to order of n square. Time complexity increases to order of n square. Okay. That is the reason even this dynamic memory allocation technique or the concept of dynamic array does not suit for your stacks. I hope you understood how we are doing it, right. So, again, how to implement this DMA you will create one block first, put 10 into that, this becomes your top. Now again you will allocate another, maybe you already created 3 blocks, so 10, 20, 30 is there, and my top is here, and my top is here. Now you see, to insert an element, we increment top index, then place the new element at that index. Okay, we increment. So for that we increase the size of S by 1. We have to increase the size of this array S by 1. How do I increase by 1? By using realloc. By using realloc. It means I have to create another block here with 4, where this 10, 20, 30 will be copied and the 4th element will come here. Okay, so that's why this has some problem. Alternate, what is the alternate for this? What could be another alternative for this dynamic memory allocation? See, here in this dynamic array implementation, I already had 3 elements, 1, 2, 3. I wanted to add new element, you are creating a new block. Again new element, you are creating a new block. So always you have to call this realloc function. Always you have to call this realloc function. As on when you want to include values, you have to keep calling this realloc function. Okay, to avoid this, to reduce this time complexity, always calling this realloc function, what is the alternative? One alternative is repeated doubling. Okay, repeated doubling. It means first you declare the size of array as a of 5 dynamically. Then when you want to insert a new element, when there comes a requirement to insert a new element, instead of incrementing, instead of making this array size S of 5 to S of 6, instead of doing this, this is the old implementation, you have to increment the size by 1. But instead of doing that, you double the size of existing array. You double the size of existing array. So make it S of 10. So this is little better, no? Why? So if I want to insert 6th element, 7th element, 8th element, 9th element and 10th element, all these 5, I can do it only in one realloc.
You have 5 minutes remaining.
In one realloc function, I am able to do that. So if you double the size, it at least reduces some number of calls. At least it reduces some number of realloc function calls, right? So it is little better compared to your basic dynamic array implementation. Okay, so in repeated doubling, what you will do? First you will take 1, then you will double it 2, then you will double 4, then 8, then 16. So even if you want to insert some elements up to 8, you can just double it 3 times, then directly 16, then 32 and so on. This is more beneficial compared to the previous approach. Why? In previous approach, you are already having 3 elements, you want 4th one, realloc, again realloc, again realloc, again realloc, again realloc. Keep calling that realloc function to insert elements. Whereas in repeated doubling technique, the number of calls, you definitely have to do that realloc function call. But the logic is that you can reduce the number of calls to log n times. You can reduce the number of calls to log n times. Okay, that is one benefit with this dynamic array implementation with repeated doubling. Again, anyhow, in this also we are unnecessarily performing order of n time complexity. Why? From that original array, that S of 3, when you are doubling S of 6, you are creating 6 and you are copying these elements from here to here. Again, when you double, you have to always copy the previous array elements into this new array. So that copying requires each element, one by one element you have to copy, which is time consuming, right? So this also has a drawback. Even the dynamic memory allocation way of implementing stacks with even repeated doubling has a drawback. Okay, for that the alternative is the linked list implementation, which we will be seeing in the next session.